Dear friends, we'll now discuss about four quadrant systems which are used in engineering graphics. They are namely first quadrant, second quadrant, third quadrant, and the fourth quadrant. Now these quadrants plays an important role in order to get the pictorial views of any object. Which are these four quadrants? Suppose take example, if we have taken two cardboard sheets, which is one kept vertical and one kept horizontal, and these two are intersecting at mid. The intersecting part we call it as reference line, and now this one cardboard sheet is divided into two parts, and this horizontal one is also divided into two parts. This vertical cardboard sheet we call it as a vertical plane, and this horizontal cardboard sheet we call it as horizontal plane. And this is the reference line xy we defined already. This is the first quadrant system, this is the second quadrant, this is third, and this is the fourth quadrant system. And this is the position of observer, which is remain constant in all the views and for all the quadrant system. Now if I am looking from this point or from this direction, here is the observer. Observer is looking to the component. Suppose component is placed here in the first quadrant. He will get the front view on a vertical plane, top view on a horizontal plane, if we are discussing about the first quadrant system. And if you see from this side, this red arrow indicates if observer along xy line in a red arrow direction will exactly appears as shown on the right side, like this one. This is the plus sign, this is the point, line becomes a point from the side, so it's xy, vertical plane and the horizontal plane, and this is the position of observer when he is looking from the front side. First quadrant, second quadrant, third quadrant, and fourth quadrant. We have transferred this three-dimensional system into two-dimensional system when we are looking from this red arrow. Now what is the difference between first angle, second, third, and fourth quadrant? We will see it clearly. When a point A is kept in first quadrant, this is the first quadrant. Now in the first quadrant, this is the point A is kept in three-dimensional system. Now observer is here. When the observer is looking from this side, he will get the projection of this point A on this vertical plane, and that view we call it as front view. It is front view always lies on VP in case of first quadrant, and its notation is A dash. And when the observer is looking to this point A from the top side, he will get a top view on the horizontal plane. And in order to convert this three-dimensional system into two-dimensional system, we are rotating this horizontal plane clockwise by 90 degree. So we are getting top view below the XY line. In case of second quadrant system, this is vertical plane, this is horizontal plane, and position of observer is remain constant here. Point A is placed now here. Observer is able to see this point A because we consider this vertical plane as a transparent one. So the projection of A will come on this vertical plane as A dash. And while looking from top to this point, its top view will come to HP here, and in order to convert this 3D into 2D, we are rotating this horizontal plane by 90 degree. So the front view and top view, both the images are coming on one single plane. Now in case of this point, it is easy to differentiate front view and top view. But if suppose the object is complicated one, or the object is assembly or bigger one, then it's difficult to read the two figures which are collided each other or which are impinged on each other. So there is a mixture of front view and top view, so we are not able to read the entire figure and it's confusing. So we are not using second quadrant system in engineering design. Reason is two images are getting collapsed, so it's not easy to read two images. Now in case of third quadrant system, position of observer is again remain constant and point A is placed here. As now I said, the vertical plane is considered to be transparent. This observer is able to get the view of point A. So the front view will come on this vertical plane, and the top view, by looking from the top side, it's again coming on horizontal plane. And in order to convert this 3D system into 2D, we are rotating horizontal plane by 90 degree. So this horizontal plane will go by this 90 degree. So the front view will come here and the top view will go up. So with respect to XY in a third quadrant system, front view is always below the XY line, and in case of third quadrant system, top view is above always XY line. In case of fourth quadrant system, this is HP, this is VP, and the position of observer is remain constant. So if I place a point A in a fourth quadrant system, position of observer is remain constant. Now while looking from this side, I am getting projection of point A on a vertical plane, that I call it as a front view. And by looking from the top side, I am getting top view on this horizontal plane. And to convert this 3D system into 2D, we are rotating this plane by 90 degree. So again, on a vertical plane, front view and top view will collapse, will collide. And it's impossible to read the figures front view and top view separately. That's why second quadrant system and the fourth quadrant system is not used in the engineering graphics.